In this video, I'm going to show you how you can take a typed array of any type of class in PHP and take an array from no auto-completion suggestions to a typed array with full object knowledge. Before we begin building our typed array class, I'd like to take a look at exactly what it is we're trying to accomplish. In this case, we have a display user array function, which takes an array of users. We iterate over each user in the list using the for each clause. And then when we go to echo out information about that user, we have to know exactly what methods and properties are available in this object. Our IDE provides no clues as there's no type information associated with the array. Contrast that with our typed list, which also functions as an array. We use the same for each data structure to iterate over it, but the IDE and the PHP interpreter know exactly what the object type is and allow us to call its methods with documentation and all of its properties. This allows us to quickly echo out name is item age, which is a method, not a property, years old. This structure also works with users with array indexing. That's the goal of this project, and what we're going to do is create from scratch a new list structure which the PHP interpreter can understand with type information. As we begin creating our typed list implementation, there are two main interfaces that are important to implement. The first is the array access interface. This interface allows us to treat our list as you would any other array object inside of PHP. The second interface is the iterator interface. Implementing this interface allows us to rewind our list and begin traversing through the list in a forward direction. This interface is used by the for each construct inside PHP. Now when we go to Now when we go to create our user list object, all we have to do is implement our two abstract methods for array access, that's implemented by the offset get method, and for each access, which is implemented by the current method. Now we change the return type to our typed class. And in the first instance, we return the offset from our list. And in the second case, we'll return our offset from this position. Implementing the typed list in this method will create a list that operates exactly like a normal PHP array. If you try to access an element that doesn't exist, you'll receive a PHP notice and return null, which means we need to make our return type nullable. Now, if you prefer, you can check if is set this list offset. If not is set, then throw new out of bounds exception. No such element offset. If you prefer to use exceptions, you can add the exception handling here. If you prefer to use the native PHP type, all you have to do is use the native implementation. Now let's take a look at exactly how this might work. Let's say we have down here, we have a new user list, and let's say list 0, and our IDE knows exactly what the item is. Let's make sure that works for being passed to a new function, users, and yep, it's accessed correctly. Now this would work just fine, but there is an issue here. Arrays is a single data structure that has two modes of implementation. An array list, which is a sorted sequence of items, or unsorted sequence of items, but it has an order. The order is maybe sorted or unsorted. And you also have a map. They're both implemented with the array interface. Here in our offset set method, we can see that we check if we have an offset, and then we insert the value into the map at the offset position. If this corresponds to list key equals value, that is the first implementation here, and the second implementation is this, for this type of call. Now, this implementation will work fine for setting the values, but it's going to be an issue when we go to increment our position for the for each counter. Because of this, we're going to need to make our implementation a little more complicated. We're going to have an additional array of keys, and whenever the is associated, whenever we set a value in the array at an offset, we're going to set the is associated flag to be true. And then when we call position, we're going to check to see if this is associated, and then we're going to return array shift this keys. Else, we're going to increment the position pointer. This is because we can't just blindly increment the internal position of the array if the array is an associated array with random key names. So the only thing we need to do now is populate the array keys whenever we begin iterating over the list. Now, fortunately, there's a method for that. It's called the rewind function. And we want to copy our is associated check here. And if it's associated, we're going to say this keys equals array keys this list. So this is going to store our list of array keys. Then we're going to say this position equals array shift, which will take the first element off the array from our keys. Else, we set the internal position counter to 0. So what this code will do is whenever we have an associated array that we're for eaching over, we'll get a list of the keys and set those to our keys, which we can just shift elements off of that list. And if we're iterating over a key, or not a key, but an array of items, then we'll just set the position to be the first element in the list. That is literally all there is to this implementation. Now we can go ahead and implement our display user items, and let's just echo item name here. And we'll go ahead and step through the code so you can see exactly how it functions. And here we go. Here's our users object with the internal list, and the list has our two user objects. If we step into this, we can see the first function that's called is the rewind function, where we check to see if our list is an associated list. It is not, so the position is reset to the beginning of the list. Then we call the valid method, which checks to make sure that the position that we're about to return is actually a valid element. If this function returns false, the list iteration stops. Then we get the current item of our user list object, which will return a user typed object from the list at the current position. Now we have an item of type user, which we can then call its properties on. And we can see it displays our Jack user and our Jill user. Now the last feature that we need to implement for our typed array is compatibility with the PHP array functions. Here we have two PHP array functions, array map and array walk. And we can see that if we just try and pass our typed list to these functions, we get an argument error. Argument 2, array, must be a type array, user list given. This is fixed easily by creating a new function on our typed list called raw, which returns the underlying array structure. Now, when we call our array map and array walk functions, we just need to pass the raw version to these methods. And we can see that these functions now work. The first function, array map, calls the user to string function located here, which takes a user and returns a string representation of the username and the user email address. The second function, echo user, takes a user object and simply echoes the username to the screen. Running this code should return an array of user strings, look like this, in display users, and it should echo the username for each user. The display users resulting array is then printed to the screen. So we should see the list of each user twice. And we can see Jack and Jill are displayed. This is from the echo user, which is called here. And then our print R displays, which returns our array of our transformed user objects. Now, an interesting thing happened. We have a PHP notice. Only variables should be passed by reference. This can easily be fixed by changing the raw method to return a reference. This tells the PHP interpreter that we're actually returning not a scalar value, such as a string or an integer, but that we're returning an array to an underlying data structure. Now, this is a little dangerous because these functions can now change the underlying data structure. They always could. Anytime you return or pass an array, the underlying data structure could be changed unless the underlying array is cloned. We can fix this with an array clone method, public function clone, return array, and then we're going to go ahead and return array clone of this list. Now, you might notice that this is not a native PHP function. Array clone is an implementation that we have in the threadfin library, which contains our base typed information. This is a utility class that I use for all of the Bitfire applications. Here's our array clone implementation. It basically takes an array and then iterates over each element in the array. If it's an array, it recursively calls array clone. If it's an object, we use the native PHP clone element, and if it's not, then we return the native value. This will recursively iterate through the entire array structure, copying every value. Now that we have a clone method on our basic data structure, we can also pass in a clone representation if we don't want it to be manipulated. We can also pass the clone implementation by reference. Now we can be worry-free that we're passing an object to our underlying data structure by reference, but the original data structure is not changed. I hope you guys found this video useful. If you use this in your code, please drop a comment below if you'd like to see more videos like this. Leave a comment for other types of advanced PHP programming videos you'd like to see. Until next time, see you guys.